Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to the first tutorial of medical image analysis course. In this tutorial we will be showing you some basic operations that you can do in MATLAB by writing a few lines of code. Our main objective is not to teach you all the commands, but to encourage you to explore the image processing toolbox of MATLAB yourself, and I hope this tutorial will help you in that. Okay, so let's start. So suppose I have an image, this image, chestxray.jpg, okay, and I want to read this image in MATLAB. So the command for this for reading an image is imread. So when you do this, the image will be stored as a matrix in the variable i0, right? And if you want to know about the size of image, you have to just write this command, size of i0, and it will give you the rows and columns of i0. For example, when I run this code, you can see it reads the image and the size of image is 1858 by 2090, almost 2000 by 2000. Okay. So this is the first thing, or the zeroth thing. Now you can do various operations on this image. For example, you can resize it. So as we saw, the original image is almost 1000 by 1000. Suppose I resize it to a very small dimension, 10 by 10. Okay, so what do you expect will happen to the image? Yeah, it will be blurred out and all the details will be lost. So for resizing, the command is imresize, and this is the original image you already have, i0, and this is the size of the output image that you want, right? It should be 10 by 10. So when you run this command, you get the resized image. As you can see, the size of image is 10 by 10 and it is very blurred as we expected. Okay, don't worry about the commands, this code will be provided to you. Also, this is just one line, right? One command, so don't worry about it. You don't have to write a code, it is just one command. Okay. So other than resizing, you can crop an image. So for cropping, the command is imcrop, right? And when we crop an image, we basically select a rectangle, right? And the dimension of the rectangle is specified here. Okay, so when you run this command, you can extract a particular section of image. This is the cropped image, this is the original image. Okay, so you can also take transpose of the image. There is no special command, simply because image is a matrix, so you can simply take transpose of the matrix, right? If I naught is the original matrix, then I naught prime represents its transpose, right? So when you run this, see, the image gets transposed. So the rows and columns are interchanged. So this is transpose. Okay. Now we show some rigid transformations to you. Rigid transformation means the shape of the image will not be distorted, right? The first rigid transformation is translation. Suppose I have an image, a chest X-ray image, and I want to translate it. Okay. So this is the translation in X direction 150. This is translation in Y direction 250, and then the command is IM translate. Okay. So when you run this command, your image gets translated by the amount that you specified. You see, this is the original image and this is the translated image. 150 in the X direction and 250 in the Y direction. So other than that, you can also rotate the image. So just like IM translate, we have IM rotate also. You can specify the angle by which you want to rotate the image. For example, here it is 35 degree, the angle of rotation, and here bilinear represents interpolation method that will be used to determine the pixel intensity in the rotated image, right? So when we run this, we get this. So you can see we have a rotated image. So in translation as well as rotation, the shape is not distorted, but you can also distort the image. How? By using by introducing shear deformations in the image. For that, you can use this affine transformation, and this will introduce shear in your image, right? Shear transformation. So here you define the transform. This T form represents the transformation, the information about the horizontal and vertical shear, and then you apply this using this command. And here you can see the shared image. Okay. So these are the basic operations. Now we go to the next section. It is some image enhancement operations. So the first image enhancement operation is brightness. Suppose you have an image and you want to increase its brightness. So what can you do? So the idea is to just simply add a constant. To the original image. So for example, original image is I0, and to brighten it I am adding 100 to all the pixel values, I0 plus 100. Okay. Similarly, if I want to decrease the intensity of the image, I have to just subtract it. So when I run this command, I get the following. Brightened image, original image. Okay. The next operation is contrast. So you can control the contrast of an image by using various algorithms. Here I am showing just 3 of them. Others are also available in MATLAB. So these 3 algorithms are IM adjust, and histogram equalization, and adaptive histogram equalization. So it is IM adjust, hist EQ, and adapt hist EQ. So you have to supply the initial image I0 and just run this function IM adjust. It will give you the give you the image with more contrast, right? So when you run this command, when you run these commands, you get the following. So here the contrast is improved by 3 algorithms: IM adjust, histogram equalization, and adaptive histogram equalization, right? This is the original one, and these are the images with more contrast. So other than contrast, you can also sharpen an image with the help of command im sharpen. So if we run this command im sharpen, you will see that this is the original image and this is the sharpened image. Okay, so clearly sharpened image is better. So these are some of the image enhancement operations that you can do in MATLAB. You can control the contrast, you can sharpen an image, you can increase the brightness, decrease the brightness, etc. Yeah. Now we come to the third part, some special filtering operations. So the first operation is blurring. So you can blur an image by using multiple options available in MATLAB. We are showing you blurring with 3 methods. These methods are Gaussian filter, box filter, and median filter. So the parameter in Gaussian filter is the standard deviation. So you can control the amount of blur by playing with this parameter. In box filter and median filter, you can specify the filter size, right? Okay. So you can go to the MATLAB website and explore more about these filters. So for these settings, if I apply these filters on the I0, I will get the following. Okay, so I get the following. You can see this is original image, this is Gaussian blurring, and blurring due to box filter and median filter. See here, if I change it from 100 to 25, the blurring will decrease in the here. You see, blurring is decreased. Okay, so this is about blurring. Another very important operation is edge detection. Again, you can use multiple filters for this, but I am showing you only two filtering operations. First is based on Canny algorithm, second is based on Pruitt filter, not algorithm, filter. So first is Canny filter, second is Pruitt filter. So there are other filters also that you can test out. So if I try to find the edge of an image using these two filters, the results, we will get the following result. So this is an image. It has a lot of horizontal and vertical edges. So with the two filters, we get the following output. Okay. Clearly here the Canny one looks better. So the filters that we discussed earlier, for example the median filter, etc., they can be used for noise removal also. So here is an example. I take an image and add some noise to it, and then I will apply a median filter to remove that noise. So for example, here is the original image, an image with some black dots, as you can see. These are the noise that I have added. But when I give this noisy image to median filter, right, it leads to this image. You can see these the noise is gone, right? So median filter can be used for noise removal as well. So these are some of the examples, and you can try many more things. So this is just to motivate you to explore the image processing toolbox of MATLAB yourself, and I hope that the things which I have shown will make you feel motivated for that. Okay, thank you.